In this section of aqueous equilibrium, we'll discuss buffers. Buffers, or buffered solutions, are special mixtures that are resistant to large pH changes, even when small amounts of strong acid or strong base are added. The reason why buffers are able to resist large pH changes is because they contain both an acidic and a basic component. Buffers are prepared by mixing either a weak acid and a salt containing its conjugate base, or a weak base and a salt containing its conjugate acid. Consider a buffer solution composed of HF and NaF. The acidic component is HF. This component aids in the neutralization of any strong base that is added to the buffer. The basic component is the fluoride ion, F-. This component aids in the neutralization of any strong acid that is added to the buffer. Let's consider that same buffer solution composed of HF and NaF. And in the diagram here, in the center, we have a buffer with equal concentrations of the weak acid HF and its conjugate base, F-. So let's say what happens if a small amount of the strong base KOH is added to the buffer. Well, if we add OH to the buffer, the OH- is going to react with the acid. Remember that the acid HF is there to neutralize the addition of any strong base. So the OH is going to react with the HF. And as it does, it's going to produce water and more fluoride ions. So that's why if you look at the amount here of the F-, it has gone up, and the amount of the HF has gone down, because the HF reacts with the hydroxide ion to make water and F-, as demonstrated by the reaction here where we have water and F-. Let's consider that same buffer solution with equal concentrations of HF and F-, but instead I add a small amount of some strong acid, which here we're calling H+. Well, the fluoride ion in the buffer solution will react with the H+ to make HF, okay, as shown by the reaction here. And in doing so, we see a decrease in the fluoride ion and an increase in the HF. So if a small amount of strong acid is added, the F- reacts with it to form HF.